All right, this is a total surprise. Normally, we don't get to this till, gosh, late in the semester or even early next semester. It's very much a surprise, but I'm glad that we're doing this. We can't prove either of these two right now. The derivative of e to the x is itself. Now, that's the weirdest thing ever. And the derivative of a natural log is 1 over whatever the x is. I can't prove it, but we can look at some examples. All right, so I'm going to go over here and we're going to say math 8, and we're going to take the derivative with respect to x of, I'm going to do the e to the x one first. So e to the x when x is, we'll do 1. All right. And so there we go. Now, of course, your calculator is going to freak out a little bit, but it's doing the best it can. It's doing pretty good, really, because that's the same to, golly, about 6 decimal places. So that's pretty good. And just to show that it works for any value, I'll do a couple of others. Let's go back up here, bring this down, and now let's try, I don't know, 4. All right. So that's that. And if I find out what e to the 4th is, and that's not the way to do that, that is the way to do it, and I deleted it anyway. Wow. Okay. And then even something crazy. I don't know. It's not a proof. It's not a proof. It's just showing you that it's working. X is 0.25. All right. So there's that. And then let's go e to the 0.25. So there we go. Okay. I mean, accurate down to, golly, tiny, tiny, tiny. So whatever, method the calculator is using, is not precise, but pretty close within, and since you're doing things to 3 decimal places in this class anyway, that's close enough. All right. And so that takes care of the e to the x. That's weird. So the function value and the slope are the same. All right. That's weird. I want to look at that just another way too. All right, there's e to the x. And if I did a trace, so trace just right there. All right, so at that moment, the y value is 2.85. Let's see if I can do, well, let's get it. I don't know if it's going to work. Let's try it. Second calculate. It'll find me a derivative on a graph. At that very moment, I see, look, the y is 2.85, right? If I hit enter, the derivative is 2.85. I mean, that's just crazy. That's just crazy. So wherever I chose, if I traced on here, all right, the y is 0.35. Let's calculate the slope at that moment. All right, at 0.35, and it's 0.35. All right, what in the world? Okay, the slope values and the y values are the same. That is unbelievable. All right, now what about this natural log one? All right, let's go over here. I'm going to go back over here, and so let's do math 8 again, and then yes, x, and then I need natural log of x. So this is an interesting one also. And so when x is 2, according to this, it should be 1/2. Oh wow! All right, so that's pretty good. Even though we got a little situation there, 3 should be 1/3. Okay, close enough. 4 should be 1/4. 1/4. Okay, all right. 10 should be 1/10. Yeah. All right. 1/2 should be 2. Right. 1/2 should be 2 because I'll be going 1 divided by 1/2. Right. So 0.5. This should be 2. Okay. 1/10 should be 10. So 1/10 is 0.1. And there we go. Okay, so not really a proof. That's not a proof. That's just looking at a bunch of examples, but gets us where maybe you can believe that it's true. All right. So now the question is then, use laws of logarithms to find the derivatives of each of the following. Well, if you recall, there was that's an exponent, and so is that. The natural log of x is e to what power gives you x. These are two. This is a power to a power. Okay. Well, then you could do this. And this is why the power rule probably wasn't a big surprise to you. Right? Okay, so I could drop the 3 down, but no subtracting of an exponent this time. That exponent just drops down. That's a logarithm rule that you did in Algebra 2 and in pre-calculus. And so now, if I take the derivative, I can do the constant multiple rule. And so it'll be 3. And the derivative of the natural log is 1 over x. So this is 3 over x. Okay, all right. All right, so okay, so that works out. That works out pretty good. Now, if you recall, this is a product of 2 results, and so those are adding exponents. And so what you can do is you can break that into 2 logarithms. This was another logarithm rule. So plus the natural log of e to the x. And now let's do a little simplifying here. This is 2 times the natural log of x. And this is e to what power is x. All right, so I can't do the exponent thing because this is just saying e to what power is e. E to what power is e to the x. Oh, okay, x. In other words, the natural log and the e cancel each other out. Right, so I mean, I guess I could still do the rule. I could drop the x down. The natural log of e is 1, and then I've got x. Okay, all right, so here we go. Now the derivative. G prime of x. As we saw over here, this is going to be 2 over x. But the the derivative of x is 1. Okay. All right, well, this one's interesting. I need to rewrite the second half, right? So I've got the natural log of x, and then minus x to the negative 1. All right, so h prime of x is going to equal, this is 1 over x. That's weird. We're back to that. But this is going to be plus, because I'm doing the power rule. All right, so that's like a 1 there. So negative 1 times negative 1, so it'll be plus 1 x to the negative 2. Ah, man, we could do some work on this. So this is 1 over x, and then this will be plus 1 over x squared. I mean, I could do a common denominator pretty quick on that, right? If we needed to, I would call that x over x squared. Yeah, you could go. Okay, now here's another logarithm rule. This was the division one. So this is the natural log of 2e to the x minus the natural log of 3x. Okay, and then I can do the rule that I did up here twice. So I've got the natural log of 2, oh man, that's a number, plus the natural log of e to the x, okay, that's x, all right, minus the natural log of a number, that's going to be the derivative of 0, minus, because I'm subtracting both of those, the natural log of x. So this is interesting. So I can clean that one up a little bit. So this is natural log of 2 plus the natural log of e to the x is x. You can drop the x down if you want to, and natural log of e is 1 because it's asking e to what power is e? 1. All right, and then minus a constant, that's just a number, and then that's your natural log of x. Okay, so the derivative of all this stuff. All right, so y prime is equal to 0 plus 1 minus 0 minus 1 over x. Okay, so of course, just clean that up a little bit. It'd be 1 minus 1 over x. Okay, cool. All right, and oh my goodness, we got 3 of them. All right, so this all simplifies as natural log of 4 plus natural log, I'm going to go ahead and go, it's natural log of x cubed. It'll be 3 times the natural log of x. And then the natural log of e to the x is x. And so now we can just get straight to our derivative. F prime of x is equal to, the derivative of a constant is 0. And this is going to be constant multiple times the derivative of the natural log. And then 1. So the 0 doesn't need to be there. So my final answer then is going to be 3 over x plus 1. Yay. Okie dokie. All right. So, all right. So that's very interesting. Is this the end? Oh gosh, it is. Okay. So we haven't even really done an e to the x one at all. Okay, but I guess that's why they threw this one in here. So we'll do that. So I can't really rewrite that. So pi e to the x. Wow, that's weird. And then minus, and I'm going to change this to x to the negative 2/3. It's kind of a random one in here. And now g prime of x is going to equal. The derivative of e to the x is e to the x, but we have the constant multiple rule. So this is going to be pi, and the derivative of e to the x is itself, which is totally weird. And then plus 2/3 x to the negative 5/3. Right? All right, and then to clean that up, I could a little bit. So I've got pi e to the x. And this is going to be plus 2 over 3x to the 5/3. And just because I'm curious, let's see how Gene left it. Did the same thing we did. All right, did the same thing we did. All right, so that is fine. All right, that's it for lesson 2.